a steel of diameter 2 millimeters falls at a constant rate of 10 centimeter in 3.4 seconds through oil in a relative large jar. Calculate the dynamic viscosity of the oil at a temperature of the test, assuming that the density, the object, and the oil is 920 and 770 kilogram per meter cube respectively. So we are seeing a case where, of course, I've written down the given parameters. We are given the steel of diameter 2 millimeters. We are given the velocity here, but the velocity is kind of coded. But we should just know that velocity is what? Distance over time. And in this case, we are given the distance as 10 centimeter. Of course, to change it to meter, you have to divide it by 100. So you have 0.1 meter. So we're having a length of 0.1 meter over a time of 3.4 seconds. That's what's the concept. So that's how you get the velocity. So if you look here, they say it falls at a constant rate of 10 centimeter in 3.4 seconds. This is what the velocity is. And this velocity now calculated is going to be taken as the terminal velocity. You should note that they say we should calculate a what? Dynamic viscosity. Now, let me give you an insight about what this viscosity is all about. We said viscosity is what? The internal resistance between the layers of the fluid, right? But taking note, there are two types of viscosity. We have dynamic viscosity and we have kinematic viscosity. What we are given here, or what we have been working with in the expression for the terminal velocity, is the dynamic viscosity. Okay, let me give you the expression for the kinematic viscosity, just for you to know. So take note that the kinematic viscosity is denoted by this. It's equal to what? The dynamic viscosity over density. So you should note that the kinematic viscosity, dynamic viscosity over the density. So just for clarity purpose, but this is not what we say we should calculate. Let's say we should calculate this, which is the dynamic viscosity. That's also for clarity purpose. Of course, some of you that are here doing engineering are going to see it in your higher levels. That is from 200 level, 300 up, when you start talking about the concept of fluid mechanics. So the next time they gave the densities of what? Oil, and density of the object, which is 920, and density of the oil as 770 kilogram per meter cube. So these are everything about the question. So first of all, we're going to start by punching this value. You punch 0.1 divided by 3.4. You have the velocity as 0.2, okay, 0.029 meter. Terminal velocity, you know that is given by what? 2 rho square g rho minus rho prime over what? 9 dynamic viscosity. If you make this subject formula, you have that this is equal to what? 2 rho square g rho minus rho prime. This will come here as a over half over what? 9 Vt. So from here you can understand the concept, and you should know that gravity is always 9.1 meters per second, where that's the value we are using. So we're going to substitute all these parameters here, but take note we are given the diameter. And if you look at this my illustration here, you can see that diameter is 2 times the radius, because we're looking at the body of the object, which is in this case a steel, and steel has a diameter of 2 millimeters. So from the concept that d is equals to 2 rho, so d rho is equals to d over 2. So in that case, you see that this becomes rho becomes 2 times 10 raised to the power negative 3. Take note, millimeters over 2. So your radius becomes 1 10 times to the power negative 3 meters. So with all this, everything is in its proper unit. We're going to substitute those values into the equation. So let's do that. Okay, substituting those values, you see that the dynamic viscosity is equal to what? 2 into 1 times 10 raised to the power negative 3 all squared. You have G, which is 9.81 into the density of the object 920 negative 770 all over what? 9 multiplied by what? What is the terminal velocity? In this case 0.029. So if we punch this correctly, you see that we have the value for the dynamic viscosity as 0.01125. Take note of the unit, Newton seconds per meter square. So this is the unit, of course, Newton seconds per meter square. This is the unit for what? Dynamic viscosity or viscosity. The concept is easy. In this case, they played with the velocity in the sense they give you the constant rate of 10 centimeter in 3.4 seconds. The distance moved or distance covered in 3.4 seconds. The velocity amount to 0.029 meters per second. So with that concept, everything is done. I believe that was the point where you need to crack your brain in this question. So this is a very straightforward question. Let's jump into the next one. Take down the second question. A small oil drop falls with a terminal velocity of 8 times 10 raised to the power negative 8 meters per second through air. Calculate the radius of the drop in millimeters if the viscosity of air is 2.8 times 10 raised to the power negative 4 Newton seconds per meter square. The density of oil is 900 kilogram per meter cube and gravity is 10 meters per second for this critical part of the equation. What will be the new terminal velocity for an oil drop of half the radius? Then we say we should neglect the density of the air. So it's a very important concept. This sample problem is different from what we calculated here. The medium at which the object falls here is what? An oil, right? But the medium in this second example, the medium is air. So when we talk about fluid, we should know that when we're talking about fluid, fluid is liquid and gas, and air is a gas. So the medium here is an oil, which is liquid. The medium in the second problem is not is air in this case. So these are important concepts you should know. So let's start by writing our given parameters. So if you look at the question, we have to determine our given parameters, which is the things that are given. So the first step is by giving the terminal velocity through air. So we're having terminal velocity Vt as 8 times 10 raised to the power negative 8 meters per second. And we are given that we should we are told we should calculate the radius, right? We are given the coefficient of viscosity through air. We are given 2.8 times 10 raised to the power negative 4 Newton seconds per meter square. Of course, we are given the density of air as 900 kilogram per meter cube. Yeah, that's what we are given. Then the second part, they say we should calculate what? The new radius. Okay, they say we should calculate the new terminal velocity. So let's just put terminal velocity here and new. Of course, we need it from the concept of the new radius, which is half of the one to calculate. So these are important concepts you should note. The way I do illustrate it is a very easy thing. So in this question, we're given the terminal velocity, we're given the coefficient of viscosity, we're given the density of air, which is the medium at which it falls. But to find the radius. After I look for the radius, we'll calculate the new radius, which is half the old radius. Then we'll calculate the terminal velocity, which is the new terminal velocity. A very clear and easy concept. Now, how do we kick off the calculation of this sample problem now? You must know formula for terminal velocity. So from the formula of terminal velocity, which is Vt, is equal to what? 2 r square g rho minus rho prime over what? 9 coefficient of viscosity. But take note, look at the critical part of this question. Neglect the density of air. Okay, take note. This is the density of the object, not air. This is the density of the object. This is a small drop. Okay, take note. See, it's a drop of oil. The object now I'm considering is a drop of oil. Here we consider a steel ball, right? In this case, we're considering a drop of oil. The density of that oil is this. In this case, the density of the object is the oil. So the should neglect the density of what? The air, which is the medium it falls through. And this is the density of the air, which is rho prime. So if they say we should neglect it, we take it as 0. So neglect the density of what? Air. Then the object in this case is the density of the oil. The object is the oil that is falling now in a fluid. So now let's say we calculate the radius, which is we have to make the radius the subject formula. Some of you don't understand the concept of subject formula. Please go and work on subject formula, because it's a very important concept in engineering. Subject formula is, let me give you what subject formula is. We're going to make arrow subject formula. Of course, you have an equation. You have Vt is equal to what? 2 r square g rho prime over 9 viscosity. Put one here, cross multiply. If you do that, you have 9 Vt, coefficient of viscosity 2 r square g rho minus rho prime. Then for us to make r square subject formula, we have to divide both sides by 2g rho prime. 2g rho prime. You see that this will go with this, this will go with this, this will go with this. You have r square is equal to what? 9 Vt, this over 2g rho minus rho prime. From this concept now, you're going to take the square root of both sides. Take the square root of both sides. See that it's just taking this and taking this. Of course, this will cancel this. Have this, so you have r is equal to the square root of what? 9 Vt, this over, of course, this is dynamic viscosity over 2g rho minus rho prime. So now we have successfully made this the subject formula, a very easy concept. So let's wipe this off. This was just to illustrate and show you how to make this subject formula. So let's move this to the other part. So we have so we have r is equal to what? The square root of what? 9 Vt, coefficient of viscosity over 2g rho minus rho prime. Since we have made r square the subject formula in this case now, we're going to substitute our parameters into the equation. So we are seeing a case where we're having r equals to what? The square root of what? We're having 9 multiplied by Vt, which is 8 times 10 raised to the power negative 8, and the coefficient of viscosity is 2.8 times 10 raised to the power negative 4, all over what? We're having 2 multiplied by gravity. In this case, take note they gave us the acceleration due to gravity. Give us the acceleration due to gravity as 10 meters per second squared. So we have this as 10. So we're having bracket. They gave us the density of the object, which in this case oil, as 900, and they say we should neglect the other one by taking it as 0. So let's punch this and get the value. So if we punch this, we have radius of the oil is 1.058 times 10 raised to the power negative 7 meters. But the question says we should calculate the radius of the ball in millimeters. Therefore, the way to do this is to convert to millimeters. Converting from meters to millimeters is the same as multiplying by what? 1000. So if you do that, you have that the radius is equal to 1.058 multiplied by 10 raised to the power negative 7. Of course, this becomes 10 raised to the power 3, right? 10 raised to the power 3. So, of course, it will add between these two. So we have 1.058 times 10 raised to the power negative 7 plus 3, negative 4 millimeters. So this is the radius of the oil in this case. But we are not done. They say we should calculate the terminal velocity, given that the new radius is half of the what? Previous radius. So the concept of the new radius we have built the concept. The new radius is 2 times multiplied by what? The old radius. And of course, this is the value we have here, which is 1.058 times 10 raised to the power negative 4. So if you do that for the new radius as what? 5.29 times 10 raised to the power negative 5 millimeters. So please, this is the new radius of the ball. But now take note, when we change it in terms of meters, it becomes 5.29 times 10 raised to the power negative 8 meters. So that's what we're going to use to calculate the new terminal velocity. So now we're going to substitute into the value of the new terminal velocity, which is terminal velocity new, of course, 2 multiplied by bracket. Of course, the new radius is 2.9 times 10 raised to the power negative 8 all squared, multiplied by acceleration due to gravity 10 into what? 900 minus 0 over what? Of course, over 9 multiplied by what? The coefficient of viscosity, which is 2.8 times 10 raised to the power negative 4. So if we punch this correctly, we have that the new terminal velocity is 2 times 10 raised to the power negative 8 meters per second. So take note, it's a very easy concept for you to understand. So thank you very much for this concept of terminal velocity, and see you in our next video.